Welcome everyone to today's lecture. And before starting the lecture, I would like to introduce myself. I am Yashasvi from Bangalore Institute of Technology, and I would also like to thank Maya ma'am for giving me this opportunity to present this presentation in front of you all to the all the future engineers. So let's begin with the topic. So today's topic is shift register, and before knowing shift register, we must know what is a register. And if we are thinking that we know register, we must also be knowing flip-flops. Okay, so what is a flip-flop? A flip-flop is a basic device which is used to store a single bit of data. Okay, we are clear with the flip-flop. And now what is a register? Register is a collection of flip-flops which is used to store multiple bits of data. So we are done till registers, and now we want shift registers. What we want the knowledge about shift registers. So what are shift registers? Here it's written shift register are type of sequential circuits. Okay, now, what are sequential circuits? So, I'm going to give you a clearer definition. A shift register is a type of digital circuit using here we use cascading of flip flops where the output of one flip flop is connected to the input of another. So, that's what basically the sequential circuit mean, and we'll study about it in detail in today's lecture. So, starting with the definition, a shift register is a type of digital circuit using a cascade of flip-flop where the output of one flip-flop is connected to the input of another, and all the flip-flops it's very peculiar and interesting that all the flip-flops share a common clock cycle, which we will study further in this lecture. Now, a register used to store 8-bit binary. These are the examples which you can self-read, which by the provided link in the description. And now when we know about shift registers, we are going to look at its type. So types of shift register. There are four types of shift register which we are going to study today and which we are going to cover in today's lecture. First of all, we will study serial in serial out, then serial in parallel out, parallel in serial out, and parallel in parallel out. Also, their abbreviation are given as follows: CISO, CIPO, PISO, and PIPO. So here are the shifts which we are going to perform, or which we can say we will consider, which we'll cover in today's lecture. So first of all, there is right shift. We provide the data bits from right, and we get the output from left. Left shift, we provide the data shifts from left, and we get the output from right. Similarly, parallel shift is like we provide the data from top, and we get it from the bottom. And considering this, all are all are very similar, which we are going to cover today. Now, moving to serial in serial out, CISO shift register. So basically, before starting the classification details, um, I would like to create a bit more interest in for you, a bit more interest for you in this topic by giving a few examples. Basically, a shift register is a piece of circuit that you will find inside a microprocessor. Now that's interesting. It is used to store data and modify the data. Now this is the basic interesting thing. Like you have this application in our day-to-day life, and you know that it's very important to have a microprocessor, obviously. So starting with the classifications now. Sorry for the glitch. We are starting with serial in serial out shift registers. So you can see the diagram here, and now I will give you a brief introduction about it. In this mode of operation, the data is fed into the shift register serially for every clock cycle. Thus, that is for every clock cycle, the data is shifted either to the right or to the left. Here we are considering the right shift. The output is taken out one bit at a time, so both inputs and outputs are serial here. Hence the name CISO comes. So then how do you think the flip-flop connection look like? So this is the flip-flop connection which look like, and it is very similar to its name. You can see we are providing the data input serially and we are getting the output serially. So we can see here um, the type of shift register accept data serially one bit at a time. Now here there is a very interesting question that many students don't ask and many teachers don't explain. The interesting question: why do we always use D flip flop? We use D flip flop because we just want to store the data and we don't need any toggling. As you all know about D flip flop, there's sorry, the size is quite large. All the about D flip flop. D flip flop is the only flip flop which provides you with such facilities. Okay, so here is G, and here we get the next output. So when clock is 0, we don't have anything, we don't care, and Qn. And when clock is 1, and when D is 1 and this is 0, then in the next state is the same value as stored in D and the same value as stored in D in both the cases. Okay, sorry for this very random structure of painting, but I hope it's clear. So here we uh, shift the data. Okay, since D stores the data, so we are using D, and any other flip flop won't, so we are not using them. Okay, now um, here in the example it's given about the data is stored by the flip flops. It's QA, QB, QC, QD. So we are considering it to be 0 initially. Okay, we are considering the data to be stored as 0. So we are considering it to be 0, it to be 0, it to be 0, and this to be 0. I'm explaining this in a bit detail so that the further coming classification will be clear to you all easily, more easily. Now in the example we are trying to insert 1010. So let's consider a different example from that. We will try to insert 1111. Consider 1111. So here we check first the least significant bit or most share. This is the least significant bit. This is the most significant byte. So we start inserting from the least significant byte. I hope it is clear. Now since we start inserting from least significant byte, this will be 1, and since we are using D flip-flop, these will retain the values. Now there will be a shift, then in after the second clock cycle, this will become, we were storing 1111, so now this will enter here, and this will be 1, and this will be 00. Now when this will enter here, then this is a 111, and this will be 0. And now when our most significant byte enters, then it will be 1111. I hope it's clear. Now moving forward um, to the next classification, serial in parallel out shift register. Okay, so let me explain you a bit about it. When we use the shift CPO, serial in parallel out register, we feed data serially. We feed the input data serially, but take the output data in parallel. So, but the data again happens, but again this happens at every clock cycle. So what I mean to say is, you can see here we are still feeding the data input serially, but the output is not serially here. So we are taking all the output bits at the same time in parallel. So what this means that we will get full 4-bit output in every clock cycle. So what we were doing in the um, CISO CISO registers, we were giving the data, giving the data, giving the data, giving the data, getting the output one by one. Okay, but now here what we do, we provide the input one. So sorry, provide the input one and provide the input one, and we get the output. Then another input, we get another output. Then another input, we get another output. So here we get input output in all the four clock cycles completely. Now, our next part is parallel and series out. So in the case of shift register in PISO mode, we feed the input data in parallel but take the output data serially. So what this means that we will be feeding multiple data bits as input for each clock cycle, but will be taking only one output bit for each clock cycle. So as you can think about it, by the above two examples you may think about a circuit diagram. So then what will happen to the output of each flip-flop? Well, even that will be fed as an input, so we'll be feeding two inputs after multiplexing them. I hope my words are clear. We will feed two inputs after multiplexing them. So giving it by diagram, so we are feeding the two inputs by multiplexing them. Okay, and these are the, so you can see here our QA is connected to B, and here we are feeding the two inputs by multiplexing them. I hope this is clear. Now we are moving to the parallel in parallel out Pipo shift register. uh, and finally we have this register, Pipo shift register. So you can guess what is this mode. Yes, in this mode of operation you have both input and output data running in parallel. So how does that work? So, okay, so you can see it's working. We are providing the data inputs parallelly, and we are getting the output parallelly. Okay, I hope this is very clear, because when we covered up our first CISO register, it was very clear how the other registers would look like, and so we are not jumping into the details of a register, but we are ourselves getting the insight about what the further registers are. Sorry. Um, so as you can see here, um, a major change in the way we connect the flip-flops, in that you don't see them connected each other to all, so each input gets goes to a flip-flop and its output is directly taken out. The only connection that is common to all these flip-flops are the clock and clear signal. So there you have it. Those are the different modes in which you can design a shift register to work. In the next section we will study more about these shift registers. So we are just connecting the input, and we are, and here is an interesting fact that this is the fastest among the all other flip-flops. And in first clock pulse, the four outputs are loaded in shift register. So this is the fastest. Um, we are just providing a clock pulse, and all we will get all the four outputs. So this is extensively used, and this is the fastest. So that's it for today's video, and see you in the next video. Thank you.